Is learning the gameplay ability system worth the effort? Yes. Is it hard to learn? Not that much. Let's find out. At the start of this video, I'll demonstrate what the gameplay ability system is and how it works. Following that, we'll develop gameplay abilities, tasks, effects, queues, costs and cooldowns, and employ gameplay events and tags. Additionally, we set up a simple user interface and bind to gameplay attribute value changes in C++ utilizing macros and lambda functions. We will cover each aspect in detail, ensuring that by the video's conclusion, you'll be able to create this kick gameplay ability functional across both listen server and client in a multiplayer game. So, what is this gameplay ability system? According to Epic Games, the gameplay ability system is a framework for building attributes, abilities and interactions that an actor can own and trigger. The system is designed to be adapted to a wide variety of gameplay-driven projects such as role-playing games, action-adventure games and multiplayer online battle arena games. I would like to add that it's a plugin that ships with Unreal Engine and that supports out-of-the-box multiplayer with client-side prediction, and it also has proven its worth in big commercial games such as Fortnite, and it can also help you realizing your indie game project depending a little bit on what you are developing. Let's talk about how the classes of the gameplay ability system work together. The ability system component is kind of the brain of the system. Actors must have this component to be able to use gameplay abilities and attributes or receive gameplay effects. The ASC must be initialized with an owner actor and an avatar actor, which is a physical representation of the owner. Both can be the same actor. If you plan to respawn or swap out your player-controlled actor, it is recommended that the owner is the player state and the avatar is the character. In this tutorial, we will implement both options. The owner actor can have a single or many attribute sets. The attribute set defines and manages changes to attributes, which are basically floats that can represent stats like health, stamina, and so on. It's up to you if you want actors to share one big attribute set and ignore some attributes, or if you want to have an individual combination of attribute sets for each respective ASC owner actor class. A gameplay ability can be anything an actor can do, for example sprinting, sneaking, picking up items or special skills like shooting arrows. They can be activated by the ASC once they have been granted. Gameplay abilities can execute ability tasks that enable them to run actions in parallel and across multiple frames, such as performing an animation while targeting an enemy. Gameplay effects are usually applied through an ability to change an actor's attributes immediately or during a certain time span. For example, your hero might have the ability to poison enemies, which causes them to lose 10 health points per second. Gameplay cues are cosmetics, like explosions that use particle effects or sounds. They are triggered by effects via gameplay tags. Gameplay tags exist independently of the gameplay ability system. They are hierarchical labels that can be used to identify, categorize, query and filter objects or to inform about an ASC owner's state. For example, that it's in the middle of a kick animation. Gameplay tags are very powerful and the gameplay ability system makes heavy use of them. Now, let's use the gameplay ability system in Unreal for a game. Before we can start, we have to go to Edit, Plugins, and here we have to activate gameplay abilities. Then I'm going to close the editor because I would like to change our source code. In the fab build CS, I'm going to move each module onto its own line, and then I add the modules, gameplay abilities, gameplay tags, and gameplay tasks to the public dependencies, and I build the project. Now, after the build finished, I add a new directory with the name Ability System. Here I add a new class. It's an actor component with the name Fab Ability System Component. I will include the Ability System component because our class is going to inherit from it. In the constructor, I set isReplicated to true. In the end, the ASC is an actor component and must be attached to an actor. In the system overview, I said this can be either a character or a player state. Let's first attach the ASC to a character. In the fab character base, I first delete this begin play function because we don't really need it here. In the header file, I add a forward declaration for fab character base. As long as we don't dereference a pointer, we can do this instead of including the whole file header. Now I can add this fab ability system component here as a U property. Basically, all our characters are going to be derived from the FAP character base, and they all are going to have a reference to the ability system component. A character that has this component should also implement the iAbility system interface. The interface consists of a single function, getAbilitySystem component. I generate the definition for that and implement the getter function. Since we are using the more explicit type, we need to include the FAP_ability_system component. Let's now add the ASC to the player state. I create a new folder, and here I add a new class which is going to be a FAP player state. I store the ability system component of the player controlled actor on the player state and not on the character. This way the ASC does not get lost if we respawn our player character. I'm going to inherit from the player state, of course. I include the necessary headers, forward declare this, and I'm going to inherit from the ability system interface. We already did the following in the character base, so let me just copy the code from there. Back in the player state, let's paste it and override the begin play function. I generate the definition for the getter, remove the begin play implementation, and again I have to include the same header as in the character base. The enemy and the player character are both children of the FAP character base and therefore already have a pointer to the ASC and implement the ability system interface. Here in the enemy character, let's initialize the ASC with create default subobject. The gameplay effect replication mode for AI controlled pawns should be set to minimal. This means that gameplay effects are never replicated to anyone. Now we can just copy paste this into the player state. For player-owned ability system components, the replication mode should be set to mixed. This will replicate gameplay effects only to the owner of that character. We set the player state's net update frequency to 100 times per second. The default value is too low and can cause a perceived lag when updating attributes, for example. Let's go to the enemy character. The ability system component needs to be initialized with its owner actor and avatar actor on both the server and the client. For this purpose, we can use the begin play function. The enemy character is also owner and avatar actor at the same time. For the player character, this is not the case. Let me just delete the tick and the begin play function, which we implemented in the previous videos. For player controlled characters where the ability system component lives on the player state, you can use the pawn's possessed by function to initialize the ASC on the server and the onRep player state function to initialize the ASC on the client. I include the required headers, and in the possessed by function, I get the player state, I cast it to a FAP player state, and I check if it's a null pointer so that we can safely dereference it. Next we can get the ASC from the player state, perform a check cast and initialize our player character's member variable with the FAP ability system component. And again we can call init ability actor info, this time for the player character on the server. But now the player state is the owner actor and the player character is only the avatar. I will extract a method from those lines, init ability system component. And I call this function in onRep player state because we have to initialize the ability system component on the client as well. In the header file I make this function private because we don't need to expose it. Now that we have our ability system component up and running, it's time to give our characters default abilities. Therefore, I'm giving my character base a T-array of gameplay ability classes. We also need a function that gives the default abilities to the character. In the function body we check if the ASC was initialized, and we also only want to give abilities if the local role of that actor is to have network authority. Next, we iterate over all the default ability classes, and then I'm going to create a gameplay ability spec. This is the data surrounding the ability class. I initialize it with level 1 explicitly, even though that's the default level. And here we give the ability to the owner actor. Now, in the enemy character, we can give the default abilities right after we initialize the ASC in begin play. And of course I also need to do this in player character in possessed by, because we only want to give abilities on the server. Okay, let's build this. Back in Unreal Engine, I create a new folder called player, and there I'm going to create a blueprint class from our FAP player state, BP FAP player state. In the game mode, I'm going to change the default player state accordingly. I compile, save, and close. And inside the characters and player directory, I'm also going to create a new folder called abilities. Here I create our first gameplay ability blueprint, say GA test. Inside of the ability, we have this event activate ability where I print hello gameplay ability. Let's give it a different color, and we shouldn't forget to end the ability. So this is kind of our hello world for gameplay abilities. And now when we open our player character blueprint, in the details panel to the right, we can add the test ability to her default abilities. When I press Q, I'd like to trigger that ability. And since we implemented the ability system interface, we can just get the ability system component, then call try activate ability by class. Here we select our GA test, and don't forget to compile and save the blueprint. And now when we press play in editor and we hit Q, we can see the message on the top left. Let's now find out how we can add an attribute set to our system. I first create this fab attribute set in C++. We inherit from attribute set and it's included automatically. I add a constructor and a health attribute, which is a f gameplay attribute data. At its core, it's just made of a base and a current value, which are floats itself. Let's go back to the attribute set and see what else we need for that. This replicated using specifier designates a callback function which is executed when the property is updated over the network. That function on rephealth can have a parameter which will automatically carry the old value before the modification. Whenever we replicate properties, we also have to override the getLifetimeReplicated_props function. And this has nothing to do with the gameplay ability system. I'm going to select everything and generate the definitions. And for now, we just need to call gameplay attribute repNotify to inform the gameplay ability system about the attribute change so that it can do anything necessary in the background, like informing the prediction system. And here, in order to make the replication work, we use this macro from the Unreal Network.h. The property will only be replicated to connections where this none condition is met, so anytime. And the property will only trigger a repNotify if this second condition is met, so always when the replication is received from the server. Let's go to the attribute set file and search for accessors. And here it states, to use this in your game, you can define something like this and then add game-specific functions as necessary. So let's do exactly that. I copy-paste and uncomment these accessor macros. I take this snippet and paste it under our health attribute, and I change it to our fab attribute set. And when I now hover over the macro, you can see that it expands to something like set health, get health, and so on. If I write health dot, you can see that we have all those functions now auto-magically. Just for demonstration purpose, I initialize the base and the current value of health with the value of 80. Back in our header file, I like to have a max health attribute with the same accessors and onRep functions. And in the same manner, I add a stamina and max stamina attribute, and also a strength and max strength attribute. In the implementation file, I add a onRep max health with the old max health parameter, and I proceed with the other attributes respectively. Don't forget to register the replicated variables with their replication and repNotify conditions. In a real game, there also might be some attributes that you don't want to replicate. Let's go back to the header file. There are functions like pre-attribute change and post-gameplay effect execute that you can override to handle attribute changes through gameplay effects. For example, the health attribute. In pre-attribute change, you first have to identify the attribute using the accessors that were generated by the macros. And then you can clump the new value that is given by reference. In this case, we don't want the health value to be negative or exceed the max health value. However, this function is not the right place to trigger in-game reactions to attribute changes. For this purpose, use the post-gameplay effect execute function. First, you have to identify the health attribute in a similar fashion, and then you can clamp the final value of the attribute. You can do so much more with this function. The data parameter provides you with access to the target, effect spec, and evaluated data. We already have used the evaluated data. It describes what happened in an attribute modification. The target is the ability system component the effect was applied to. We can also get the ability system component of the instigator of the effect from the effect spec through the effect context. You can access the owner actor from both target and instigator through the ability actor info. And from here you can access everything related, like the actor location. However, we don't need it in the moment and our attribute set is ready to go. Now let's add our attribute set to the character and player state, just like the ability system component. Again, I start with a fab character base, and I'm also going to add a getter function. Epic actually recommends to initialize attributes through a gameplay effect. Therefore, I give our class a default attribute effect and a function to apply this effect. GetAttributeSet just returns the attribute set. In the other function, I first check for null pointers and then I make an effect context. So what is this gameplay effect context handle? It is basically a wrapper that holds a data member, which is a fGameplay effect context, which itself stores the instigator of the gameplay effect and related data, such as positions and targets. The source object that created the effect is the character. We also have to make an outgoing effect specification that returns this spec handle. This handle again stores a data pointer that can be used to reference the effect specification. To make the specification, we need the effect, level, and the context that we created before. And finally, we can apply this effect to the character. Don't forget to dereference the data pointer that we get from the spec handle. Let's now go to the player state to add the fab attribute set and the getAttribute function, just like we did this in the character base. In the CPP file, we include the header and implement the getter as usual. But this time, we also initialize the attribute set with createDefaultSubObject in the constructor. In the enemy character, we again create the attribute set in the constructor, and then we just have to initialize the default attributes in begin play. Then in the player character, we get the attribute set from the player state, and we call the init default attributes function on the server and on the client. Okay, let's build the solution because I want to show you how you can debug your ability system and make your attribute values visible. I press play in editor. If your mouse cursor disappeared, press Shift F1 to unhide it so that you can go down to the console and enter the command show debug ability system. With F11, you can enable the viewport's full screen mode. Now you can see some debug information for the BP player character 0. If we had more than one actor with a ability system component, we could cycle between them by pressing page up or page down. However, if you want to make this work, you have to go to your project folder, to config and to game default ini, and here you have to paste this in order to make it work. Back in the viewport, we see more information about our actor, like the location, so if I move, you see it's going to change. Our actor doesn't own any text right now, but we'll get to this later in the video. And finally, we see that all our attributes appear and everything is set to 0, except for the health, which we set in C++. But this is not the correct way to do this. I just want to show you that it's possible. As I already mentioned, Epic recommends to change those values through a gameplay effect. And this is exactly what we are going to do next. So I'm going to add a new blueprint class, a gameplay effect, and I call it GE player default attributes. In this data-only blueprint, we have to choose from different duration policies, which I will explain later in the video. But for the attribute initialization, we need an instant effect. I add a modifier for each attribute that I want to initialize, and then I'm going to expand this. I choose one of our attribute health. The modifier operation has to be an override, and the magnitude should be, say, 80. I speed up the following part in which I do this for each attribute. But you can see my values here that I use to initialize the attributes. Do you remember that health is clamped by max health when a gameplay effect is applied? To make this work, we actually have to initialize max health before health. That's why I moved this entry to index 0. Let's now open the player character blueprint, and here in the class defaults we can select the default attribute effect. Compile, save. And now, let me just make this a little bit smaller. If we hit play and type show debug ability system again, we can see the values here. I stop this session. I go back to our abilities folder. And now let's delete our testability and create something more fun. I want our player character to have the ability to kick. A real-world kick must be animated, of course. I got this animation thanks Mixamo, and I performed a retargeting to our Quinn skeletal mesh. Let's check out quickly how it looks like. From this kick animation, I create an anim montage following Epic's naming conventions. Before we are able to play the montage, let's open the character blueprint, because we need to find Quinn's anim blueprint, which is inheriting from the male version Manny, so let's open Manny's blueprint. And here we just have to add a default slot before the output pose so that the anim montage plays correctly. We compile, save and close the anim blueprint. Let's go back to the ability folder and create a gameplay ability called GA Kick. From the event activate ability, we drag out the ability task, play, montage and wait. The clock icon on the top right indicates that this is a latent node. To perform actions that happen over time or require responding to delegates fired at some point later in time, we use latent actions called ability tasks. Those delegates correspond to the multiple execution pins, which I connect to the end ability node. Let's take a look into the C++ class that constitutes this blueprint node to understand what is happening under the hood. The play, montage and wait is an ability task that has a couple of delegates, and those delegates correspond to the execution pins. In the header of the ability task, it is denoted that they are latent and asynchronous in nature. Asynchronous tasks always make use of a function that follows a factory method design pattern. This static function creates a new object of the type of the template and returns this new object. The object is actually an instance of the class itself that is derived from the ability task, in our case the play, montage and wait object. Just one side note, in the end ability function of the gameplay ability, all tasks finish and are cleaned up automatically. So don't forget to call the end ability function. Back in the blueprint, we have to select the kick montage. Then we go to the player character, and in the class defaults, we granted GA Kick as the default ability. We want to activate GA Kick when we press Q. And now if you hit play and we press Q, we see we are kicking. And if we play Q once again and again and again, we see it's interrupting the running ability, and we don't want this. So what can we do about that? We can go to our kick ability to try to block the execution while it's running. And this is one of the many applications for gameplay tags. In order to create a gameplay tag, we can go to the project settings, gameplay tags, and under manage gameplay tags, I create this gameplay.ability.kick. We also have to select the source, and then we can add this tag. Now in the gameplay ability, we can assign this as the ability tag. Here you can see also the hierarchical nature that make gameplay tags so versatile. I also want to add another tag, gameplay.stateIsKickin'. Activation own tags are given to the owner while the ability is active. So when the player character is kicking, it's going to have this tag. I assign the same gameplay tag to the activation block tags. As long as the owner has any of these gameplay tags, this gameplay ability cannot be activated. Compile, save. I just moved this a little bit down, press play. I'd also like to see our debug info. And now if you look to the left, under own tags, when I press Q, You see the gameplay tag is kicking. When I press Q multiple times, the activation is getting blocked. This was a very straightforward solution to our problem. You will need to block abilities and use gameplay tags for various different reasons in the future. Let's make the kick have some kind of impact onto other actors. On the player character, we go to the viewport, we select the mesh component, and I add a sphere collider. I name this Foot Collider. Under the details panel to the right, I uncheck hidden in-game because I want to see what's happening. Then under collision presets, I check overlap only pawn. But actually for now I want to select custom to set it to no collision. Now I'd like to attach the sphere collider to the right foot of our player character's skeletal mesh. In the event graph, I zoom out a little bit, go up here, zoom in, and I drag this event begin play out. Then I would like to say sequence, and I move this down. Then I need a branch to check if it has authority. And if it has authority, we can say attach component to component Foot Collider. Now I'm going to get the mesh. I move this down a little bit and connect the mesh here. I also straighten the connections with Q, and I would like to know what goes into this socket name. Therefore, I click on the mesh and open it. Then we go to the skeleton, and here I'm going to search for foot, and you can see the right foot here has already a socket. We take this name and close it. And now paste what I just copied here and say snap to target, so that our collider is attached to the foot and follows the movement of the kick animation. You really don't want to miss to check component replicates, otherwise it's not working for multiplayer. And then I click on component begin overlap to implement what is happening when the Foot Collider overlaps. First, I want to check if the actor the Foot Collider is overlapping with is not the actor itself. If that's true and the Foot Collider is overlapping with another actor, I want to print an on-screen message hit. I also would like the collider to be enabled only in a certain time span during the kick. For this purpose, I create an unnotify state and I name it ANS Collider. And here I'd like to override this received notify begin function. From the mesh component, I get the owner and I cast it to our player character. Then I connect everything and I search for set collision enabled for the Foot Collider. And here select query only, no physics collision. Now I copy this and I override the received notify and function. I paste it, connect everything, and I set the Foot Collider to no collision. So now when the notify state begins, we enable the Foot Collider, and when the notify state ends, we disable the Foot Collider. So what's left to do is to specify when exactly those two events happen. I open the anim montage, pause the animation, and on the notifies track, I right-click, add notify state, and select our ANS Collider. I move the notify begin to a point where we'd like to activate the Foot Collider. Say here we have enough punch in the kick. And maybe here it's not going to cause any harm and we deactivate the collider. Before we hit play in editor, I change the number of players to 2 and play as listen server. Now you see the collider moves with the foot, and when I kick the other pawn, you see the message in the top left. Now in the player character, let's delete this and replace it with something that actually has a real impact onto the other character. Therefore, I'm using this send gameplay event to actor. We can make the payload because this is a data structure that is sent alongside the event. The instigator is the player character herself. From the collider overlap event, I get the other actor for the target, and I also want the ability target data of that actor. Looks a bit messy, I just clean it up quickly. Select this, press Q, and I select those and press Q again. Now we have to specify an event tag. I select the source and then I write event, montage, kick, add new tag. Now let's receive this event in the kick ability. I delete this, and right after we start the kick montage, I want to wait for the gameplay event here. And we of course have to compare against the same gameplay tag, and we only want to trigger it once. I pull out this payload and break the gameplay event data. From here we can access the target data and say apply gameplay effect to target. I'd like to show you two different kind of gameplay effects, so let me copy and paste this node. I'm going to apply both effects to the same target right after we received the event that was sent from the character after the foot collider overlapped. I clean everything up. Later we have to select the gameplay effects that we want to apply on hit here. So let's close this and create the actual gameplay effects. The first one is G-Kick, which is dealing damage based on the strength attribute. It is causing an instant change to what we want to modify, which is the health attribute. We want to add a magnitude that is going to be an attribute-based magnitude with a coefficient of -1, because we actually want to subtract the value. And the backing attribute is the strength coming from the ability owner. The opponent should be able to recover the health after the impact. Therefore, I create another gameplay effect, GE Recover. This is not an instant, but a periodic effect with the duration policy has duration. I set the duration magnitude to 4, so it's going to be active for 4 seconds, and it has a period of 0.1 seconds. I uncheck this because otherwise the effect would be applied once too often. Then I use a modifier for the health attribute that adds exactly 1 health. This modifier is applied each 10th of a second for a total duration of 4 seconds, which means it is going to add 40 in total. Back in the kick ability, I select the two gameplay effects that we just created for the nodes apply gameplay effect to target. Save, compile. I close everything that is kind of in the way. Then I press play and write show debug ability system as usual, and with page up I switch the player. And now when I kick my opponent, you see the health is reduced by 45 and then it recovers immediately. Perfect. If we go to the kick ability, you can see there is a cost gameplay effect and cooldowns. I want to create those now. I create a new blueprint class, again of type gameplay effect, and I call the first one GE Kick Costs. Costs are predefined amounts of attributes that the ability system component must have in order to activate the gameplay ability. They are implemented as instant gameplay effects. I want the aggressor to pay 30 stamina points for kicking. Compile, save, close the kick ability, and we select this gameplay effect for the kick cost class. I'm going to create another gameplay effect. Of course, this is going to be the cooldown effect. Cooldowns are just timers that prevent the gameplay ability to be activated again until it expires. For this reason, cooldowns must have a duration. I'm giving it 3 seconds. Cooldowns also must have a component that grant tags to the actor. We first have to create the tag that is granted to our actor during the kick cooldown. I name it gameplay.cooldown.kick. I compile and close this, and I go back to our kick ability. Here we can select the cooldown. Before this is going to work, we must go to the event activate ability and call commit ability. If you take a look into the gameplay ability source code, we see the commit ability function which calls commit execute. And in commit execute, the cooldowns and costs are applied. Now let's test if everything works. I press play in editor. I enable the debugger again to observe my stamina attribute. I hit Q to kick, the stamina is reduced, and I also cannot press it in this 3 seconds cooldown. Okay, this is all great, but I would expect my player to recover its stamina too. To realize this, I duplicate the recover effect and rename this. I also rename the other effect. In the recover stamina effect, I'm going to select the stamina and I want the magnitude to be set by the caller. Here we need to assign a data tag. I call it gameplay.magnitude.duration. Back in the kick ability, I move this quite a lot to the right because I want the player to recover right after starting the montage. And here I call assign tag set by caller magnitude. Right after that, I call apply gameplay effect to spec owner. And here I make an outgoing effect spec. I select our gameplay effect and the data tag we just created in the effect blueprint. Don't forget to connect this here. And finally, we set the magnitude, that is the effect duration, to 3 seconds. In the effect we set recover 1 stamina point 10 times a second. Now for 3 seconds makes 30 stamina points. So when we kick now, we lose 30 stamina points through the effect cost, and then we also recover those 30 total points. Let's now spice up everything with a gameplay cue. Gameplay cues are cosmetics like sound or particle effects that are typically replicated but do not affect the gameplay. I first get an animation of the opponent reacting to the kick. I select the skeleton, import all, and I also would like to add a sound. I convert this into an Anon montage and name it AM Hit React. And I'm going to add a new blueprint class, this time a gameplay cue GC kick target. We first want to override the onExecute function. I connect this to the call of the virtual parent function. I give us a bit more space. I take this target, which is an actor, and I cast it to a character. I use the character's play on a montage node to play the hit react animation. And I'm going to play a sound at location that is going to make the impact of the kick more vivid. I connect this. I just resort everything by pressing Q. Now I select our hit react montage and also our cartoon punch sound. For this node we need a location, of course. So I get the actor location that we can plug in here. Now in the class defaults, we have to assign it a gameplay tag. Here we can only choose from gameplay cue subtags, say kick. I select the source and our tag, compile, save and close. Finally, we have to trigger the cue from the appropriate gameplay effect, in this case GE kick. Again, this is really easy because we just have to go down here and select the appropriate gameplay tag. Now when I press play, I move around the character and kick it. You can see its reaction and you can also hear the sound 2 times. One time on the client and one time on the server side. Finally, I want to show you how you can display your health and stamina in your user interface by binding to the attribute value change delegate. In our FAB directory, I create a folder for user interfaces, and here I right-click user interface, widget blueprint, user widget with the name WBP attributes. In the palette, I search for canvas. I'm going to use it here. We also need a vertical box so that child widgets are laid out vertically. In the details window, I changed the anchor to be at the top in the middle. I changed the position and size. And I set the horizontal alignment to 0.5. Now I add an overlay, because an overlay can have multiple children that we can stack together. I wanted to fill the vertical box entirely. Then I add a progress bar, and I wanted to fill the overlay horizontally and vertically. I give the progress bar 50% to see how it looks like. I quickly change the style because I would like it to have a different background. I change the tint to black with an alpha of 0.5. I also give the bar a text. Now I duplicate the overlay group because I want to show you that you can actually select and change the properties of multiple UI elements at once. I changed the padding so that they don't stick together. The font size could be a bit smaller. I also want to vertically align the text to the center and give it 5 pixels to the left. Now I change the text individually. 1 to health and 1 to stamina. And I also would like to change the fill color of the health bar to red. Now we need a place where we can create and manage widgets and add them to the viewport. I think the HUD class is perfect for this. The only thing that we have to do in the HUD blueprint is to create the attributes widget in the event begin play and add it to the viewport. We also have to set this as the HUD class in the game mode. And now when I press play, there's a HUD in both client and listen server, but it actually does nothing. So let's bring our HUD to life by binding to the attribute value change delegate in C++. In the fab build CS, I add the UMG module to the dependencies. I also add a new folder UI and a class with the name attributes widget. I change it to inherit from the user widget because this is going to be the base class of the WBP attributes that we created previously in the editor. I'm going to add two properties, health and stamina percentage, only for the progress bars, and I add this bind to attributes method with the empty definition. We also need to create a HUD class as a base for our blueprint HUD here in C++. The HUD stores a reference to the attributes widget class, which I forward declare. In the private section, we store the instance of the actual widget. And we also need a function for the initialization. In this function, we create the widget instance from the widget class. And then we call its bind to attributes function and add it to the viewport. Let's now go to the player character and create a function that initializes the HUD. In this function, we first get the player controller. When it's not a null pointer, we can get the HUD from the player controller and call the HUD's init function. We have to initialize the HUD here in the right order after the ability system component and the attribute set have been initialized in order to be able to bind to the attributes. Let's go to the HUD's init function, which calls the bind to attributes function. And here we would like to implement the logic that informs our widgets about attribute value changes. I first include the fab attribute set and also the fab player state. Then I get the owning player state, and from that the ability system component and attribute set. Now that we have everything together, we can calculate the health percentage from the initial values of the attributes. Get numeric value returns a current value, and we have to divide this by the max health value. This expression looks a bit bulky and is really hard to read. So I copy this, open the fab attribute set, paste it, make it a comment and turn this into a handy little macro. So what do we actually have here? There's the fab attribute set 2 times and the get health attribute contains health, which is a property name. I'd like to have those as parameters. I define a macro with the name numeric value with the respective parameters attribute set name and property name. In the next line I write attribute set name followed by an arrow operator, and now I use the token pasting operator, which are those double hashtags, to join property name with the get and the attribute tokens to dynamically generate the correct function call where we need it. We end this line by calling get numeric value with the attribute set name, and I delete the comment. Back in our widget, we replace this with a macro that we just created with the parameters being fab_as and health. We divide this by the numeric value of max health. And then we do the same to initialize the stamina percentage. Now what's left is to finally bind to the attribute changes. From the AC, we get the gameplay attribute value change delegate for the health attribute, and here we can bind to an anonymous function with @lambda. Lambda functions are a very useful concept that exists in other languages like Python as well. In C++ they start with square brackets. Here we specify that we'd like to be able to access a copy of pointers to this class and fab_as inside the lambda function's body. But how do I know the type of this argument? I can click on this return type and you can see that it's a const f on attribute change data reference. This data parameter contains a new value, which you can divide by max health to update our health percentage. We do the same to update the stamina percentage whenever this attribute changes. Now that we are done here, we can build the solution. Back in the editor, we go to File to reparent the widget blueprint to our new attributes widget class. Then we select the progress bar, and in the details panel, we bind this to health percent, and I select the other progress bar and bind it to stamina percent. I compile and save it, and now in the class settings of the HUD, I reparent it to the Fab HUD class. I select the WBP attributes as the attribute widget class. I delete everything, compile, save, and I press play in editor. Et voila, when I use a client to kick the server and I use the listen server to kick the client, you can see that everything works as expected. Of course, there's so much more to discover of the Gameplay system, and at this point I would like to thank the authors of the unofficial documentation. It really helped a lot. You find a link to it in the video description. If you have any questions, feel free to leave a comment, and if you enjoyed the video, I would be happy about a like or a subscription. Thanks for watching. See you next time.